Okay. Now I didn't know what to call it, so I just said the supplemental chapter section 1 because it's easy to type it and I didn't really care. But what we're doing is we're going to graph linear equations. This is something that you should write down. This is something that's important and true and something that you need to keep in mind. That a graph is a picture of all of the solutions to an equation. Okay? A graph is a picture of all the solutions to an equation. Now, a linear equation has two variables. It has an x and a y. It may have an a and a b. It may have an m and a t, whatever. It's got two variables. Okay? And the solutions to an equation that has two variables is an ordered pair. It looks like this. You guys have done this before. Okay? Like 4, -1. This is always the x. This is always the y. Okay? You guys remember doing that? Plotting points and that sort of thing? Okay? This thing is called an ordered pair. Okay? You need to have that vocabulary. So when you see ordered pair, you know, oh, you just mean a point. Yeah, x and y, a point. All right? Now, I'm going to scoot down here. I'll come back to example 1, but I want the space below this to show you an equation. Okay? Do you guys need me to go back up for a second? Okay. Let me go right here. Now down here I'm going to write x plus y is equal to 5. Okay? And over here I'm going to write what's called a table of values. I'm going to draw a table of values. Some people call it a t-chart. Okay? Can you think of an x and y together that equal 5? Raise your hand. Alex?
3 and 2.
3 and 2. Sure. Can you think of a different one? Yeah. 4 and 1. Absolutely. What else? Anything else, Carlos?
10 and -5.
10 and -5. Absolutely. Robert?
6 and -1.
6 and -1. Cameron?
You do 2 and 3 the other way?
You could do 2 and 3 this way. Absolutely. Okay? You could do 5.1 and -0.1. Right? Let me ask you this now. How many solutions are there to that equation, Cameron?
Infinite.
Infinite. There's an infinite number of solutions to that equation. That's why the line that represents those solutions goes on forever and ever, off the board, down through the floor, out through the gym, into the Earth's crust, and then back out into space on the other side of the planet. Or straight off the board this side, up through the roof, and out into space. There we go. Gone. All right? Because it goes on forever and ever and ever. Okay? And all the little spaces in between are filled with solutions. If I pick a point like that point right there, that point is 3, 1. It is a solution to the equation x plus 3y equals 6. This point, 1, -1, is not on the line. It's not a solution. Okay? Now I'm already jumping ahead of myself. Let's go ahead and look at example number 1. Easy stuff. Okay? Example number 1 says, use the graph to decide whether the point lies on the graph of x plus 3y equals 6. Justify your answer algebraically. Remember, this is a picture of all the solutions to this equation. Cameron, 1, 2. Does it? We go from the origin, we go over 1 and up 2. It's close to it, but it's not on it. So it's not a solution. All right? But they said justify it algebraically. All we do is plug it in. X plus 3 times y equals 6. Plug in 1 for x, because it's in the x spot. Plug in 2 for y, because it's in the y spot. We get 1 plus 6 equals 6. 7 equals 6, and that's not true. Okay? Now, Robert, what about -3, 3? Is it a solution to this equation?
Yes.
Go back 3, 1, 2, 3, and then up 3, and it is on there. Okay? Quickly, I'm going to see if I can solve it. I'm going to put in -3, 3, -3 plus 6 equals 6. I'm sorry, plus 9, 6 equals 6. Done. Wow, and I got time left over. I'm just going to relax for a few seconds. Okay, it does work.